Welcome to Data and AI with Varath. In this channel, we will break down everything from data engineering and analytics to machine learning, artificial intelligence, and modern data architecture. Today, we start with a simple question. How is data actually generated? Every click, every search, every mobile app you open generates data. From banking to e-commerce to social media and IoT devices, the world runs on digital events. These micro-actions become the foundation of analytics and AI. Data comes from many sources: a login attempt, a card swipe, a Google search, a location update, a YouTube watch event, a warehouse scanner reading a barcode, or a sensor detecting temperature. These tiny interactions, repeated millions of times, generate massive amounts of raw data. Raw data is rarely useful. It is incomplete, duplicated, noisy, and unstructured. Before analytics or AI can use it, data must be collected, cleaned, transformed, validated, and enriched. This is where data engineering starts. Data engineering is the bridge between raw data and meaningful insights. Without pipelines, governance, and quality checks, companies cannot make reliable decisions. Every AI model, dashboard, and forecast depends on high-quality data. The rise of cloud, mobile, and IoT triggered the big data era. Companies went from storing gigabytes to terabytes, petabytes, and even exabytes. As data grew, so did the need for scalable data architecture and distributed systems. Old databases could not handle real-time streams or billions of records. That led to the creation of Hadoop, Spark, Kafka, NoSQL databases, and cloud-native warehouses like Snowflake, BigQuery, and Azure Synapse. Once data is engineered and clean, it becomes powerful. Analysts use it to build dashboards. Data scientists use it to train machine learning models. AI systems use it to make predictions and automate decisions. Clean data fuels business growth. Power BI, Tableau, Looker, and other BI tools help companies understand performance, but their insights are only as good as the underlying data. High-quality data ensures accurate KPIs and reliable decision-making. AI systems and machine learning models learn from historical patterns. Without clean, labeled, and high-quality data, even the best algorithms will fail. Data is not just an input to AI, it is the foundation. Data is generated, ingested through APIs or pipelines, stored in lakes or warehouses, transformed using ETL or ELT processes, validated for quality, and finally consumed by dashboards or AI models. This is the modern data lifecycle. Today's architectures use hybrid patterns: batch processing with Spark, real-time streaming with Kafka, data lakes for raw storage, warehouses for analytics, and feature stores for machine learning. Architecture decisions depend on business needs. If data is missing, duplicated, or inconsistent, everything that depends on it becomes unreliable. Data quality frameworks, governance rules, and monitoring systems ensure trust and transparency across analytics and AI. Organizations invest in data platforms because data reveals opportunities, customer behavior, operational issues, and new revenue streams. Data transforms companies from reactive to proactive decision makers. Whether you are a beginner or an experienced professional, learning data engineering, analytics, and AI opens the door to high-growth roles. This channel will guide you through real-world concepts step by step. In this channel, we will explore ETL pipelines, SQL and Python, cloud services in Azure and AWS, Power BI, machine learning, data architecture patterns, and hands-on projects. Everything explained in a simple and practical way. This is just the beginning. Every week, we will break down complex topics into simple lessons. If you want to grow your career in data and AI, you're in the right place. If you found this helpful and want to learn more about data engineering, analytics, and AI, make sure you subscribe. New videos are coming that will help you master real-world data skills. Welcome to Data and AI with Varath.